And let's finish out domain 5 with the authentication protocols we use for access control. And they are cryptographic or communication protocols that are designed to transfer authentication between two entities and do so securely. And they are also most often using mutual authentication. They authenticate to the connecting entity, whatever we're trying to access, often a server, and then we authenticate ourselves. That could also be a server or a desktop. How we use it and how much we need to authenticate really depends on the protocols we use and how we configure it. So let's look at some of the protocols we have used and some of the ones we use now. One of the big ones is Kerberos. It works with tickets that allows our nodes to communicate over a non-secure network, where both can prove their identity to the other in a secure manner. The protocol was named after Kerberos or Cerberus from Greek mythology. That's the three-headed guard dog of Hades. And this is based on the client-server model, where we have the mutual authentication of both the user and the server verifying each other's identity. In Kerberos, messages are protected against eavesdropping and replay attacks. Kerberos builds on symmetric keys, and it does require a trusted third party, and it can optionally use PKI during certain parts of the authentication. Kerberos uses UDP port 88 by default. You can change that. And it has been used in Active Directory from Windows 2000 and onwards, and it is also used in many of the Unix OSs. The pros are it's really easy for end users, you have the centralized control, and it's easy to administer. And then the cons. It has a single point of failure, and an attacker can gain access to everything with a single password. Let's look at how Kerberos authentication works. In the graphics over here on the right, the laptop at the bottom is my computer, the server on the right is a file server I'm trying to access, and then we have a KDC, or Key Distribution Center. The Key Distribution Center is made up by an authentication server, or AS, and a ticket granting server, or TGS. For the exam, I honestly don't think you need to know every integral part of Kerberos, but I would understand the traffic flow and what each part of the KDC does. From my laptop, I request a ticket granting ticket from the authentication server, sending it my plaintext user ID. The authentication server does a user lookup in the Key Distribution Center. It sends you two messages back. It sends you the ticket granting server session key and a ticket granting ticket. You then send that to the ticket granting server. You send an authenticator, which is your ID and a timestamp, and then you send the ticket granting ticket. Yeah, I know, it's a lot of ticket. It looks up the ticket, it sends you back a session key and a ticket. You send that ticket to the file server, along with your authenticator, which is your client ID and timestamp. All of these, of course, assume that you have the rights you need to access what you're trying to access. If you do, the server will send authentication, and you can now communicate with the file server. Because of the issues with Kerberos, Sesame was developed. Secure European systems for applications in multi-vendor environments. Yeah, let's just call it Sesame. And while it is much smarter and more secure, it's not widely used because Kerberos still comes natively with most operating systems. Sesame uses PKI, or public key infrastructure, which is asymmetric encryption, which fixes the problem Kerberos had with plain-text storage of the symmetric keys. And then instead of the tickets that Kerberos uses, it uses a privileged attribute server and privileged attribute certificates, but not widely used because, well, Kerberos is there already. Radius is another of those protocols that there are safer and more secure alternatives, but we still use this because, well, it's there already. And Radius is an abbreviation of Remote Authentication Dial-In User Service. I have never, ever heard it referred to as anything other than Radius. And it is used to perform pretty much all the A's of the IEEE model: authentication, authorization, and accounting, or auditing. And it is very widely used on network devices across many organizations. That could be access points, VPN, servers. It uses a client-server protocol that runs on the application layer of the OSI model, and it can use either TCP or UDP for transport. And the devices on our network that we use Radius for would have a Radius client that would then connect to the Radius server. Since Radius is a vendor protocol, it uses a port above 1023, it uses UDP port 1812 for authentication and 1813 for accounting. But you do have the option to use TCP instead of UDP. If you do that, you can use TLS for security. Diameter was supposed to replace Radius. See that clever play on words there? Diameter, Radius. It does pretty much the same thing, provides the authentication, authorization, and the accounting that we need for any device on our network. But that move never really happened. And I think one of the largest barriers to entry is that by default, most switches and most access points are implemented with radius, and there is no direct backwards compatibility. There is, however, an upgrade path, but then again, that's more work. Diameter is still widely used, but it's very much used in the 3G and the 4G space today. I have to admit, I don't think I've worked anywhere where we use diameter. I have, however, worked at a lot of places where we use radius. Or the next one, TAGX. Well, really, TAGX Plus. I don't think I've heard anyone use anything but the abbreviation. But if you need to know, it's the Terminal Access Controller Access Control Systems. Let's just stick with TAGX. The original version, which we do not use anymore, would require users both to send their ID and a reusable password for authentication. It would use UDP and TCP port 49, but not really used anymore. Either people have switched to Radius or TAGX Plus. With TAGX Plus, we have much better password protection because we're using two-factor authentication. But there is no backwards capability with TAGX. TAGX Plus only uses TCP port 49 for authentication with the TAGX Plus server. It is very similar to Radius, but Radius only encrypts the password, whereas TAGX Plus encrypts the entire data package, which makes it more secure. PAP, or Password Authentication Protocol, is another legacy protocol you need to know for the exam. It is not and should not be used anymore because the authentication session is initialized when the user or the client sends their credentials, their username and password, but they are sent in plain text, which you obviously know is a horrible idea because anyone sniffing our network now has the credentials to log into our systems and do damage. CHAP, or Challenge Handshake Authentication Protocol, fixed some of those problems, but still has issues on its own. It has protection against replay attacks, and it does that by using an incrementally changing identifier and a variable change value. With CHAP, both the client and the server needs to know the plain text of the shared secret, but it is never sent over the network, which obviously is smarter than PAP because both of those were vulnerabilities on PAP. CHAP uses PPP servers to validate the remote clients, and that's the point-to-point protocol we talked about earlier. And it also periodically verifies the identity of the client using a three-way handshake, just to ensure that no one has hijacked the session. So that's all the good stuff. But CHAP still stores a plaintext copy of all the client's passwords, meaning if an attacker got access to our CHAP server, they would have every single client password that was stored on it. We always want to store every password using hashing with salting, because hashing is a one-way function, and salting gives us protection against rainbow tables. And used in pretty much any organization I have ever worked in is Active Directory. And Active Directory was a protocol that was developed by Microsoft for Windows domain networks, and it is included in almost every Windows Server OS as a set of the processes and the servers they come installed with. Originally, it was only in charge of a centralized domain management, but starting with Windows Server 2008, AD is really an umbrella term we use for a wide range of directory and identity-related services. And hopefully, you do not have any Windows servers that are older than 2008 in your environment. The version before that, Windows 2003, has not been supported and has not been patched by Microsoft for 3-4 years now, meaning they have a ton of known vulnerabilities that attackers can exploit. A server running Active Directory Domain Services, or ADDS, we would call a domain controller. It would authenticate and authorize all subjects on a domain, and our networks can have a single or multiple domains. AD uses LDAP, Lightweight Directory Access Protocol, version 2 or 3. They are Microsoft's version of Kerberos, and DNS, a domain name server. If we have our network segmented into more than one domain, each domain can have separate authentication processes, different users, different network components, and different data objects. And AD, if configured right, will very heavily use groups to control the access by users to data objects. This is how a lot of organizations use RBAC or role-based access control. Bob is a network administrator. When Bob joins the organization, he gets added to the network administrator AD group. That AD group has a bunch of rights assigned to it. That way, Bob has the same access rights as all the other network administrators. If Bob changes position, we just move him to the new group, but remember to remove the old one. And if we use attribute-based access control, this can be even more granular. Remember if-then statements. The server team, all of them have access to the server room. but Thor might work as a project manager, so by default, I do not have access. But it can check the policies and see Thor is working on a project for the server team in the data center. Thor now has access to the data center. And then finally, Active Directory uses trust domains. And we use those to allow users from one domain to access resources in another. A one-way trust means someone in domain A can access data in domain B, but people in domain B cannot access things in domain A. Hence, one way. Two-way trust. A and B can access A and B. We can also talk about a domain forest. We may not just have one or two, we might have 10 or 20 or 30 domains. Then we can say, these other domains are trusted. If they then trust us, everybody can access everything. Transitive trust, you can think of as if we have domain A, domain B, and domain C. I'm in domain A, I trust domain B. Domain B trusts domain C. I don't really know anything about domain C, but because B trusts it, I trust it. That's transitive trust. And then intransitive trust or non-transitive. If we use the same example, I trust B, B trusts C. That doesn't mean I can access anything on C because I don't know C. I don't trust them.